first video in the PMP training series, in which I have given a question that is very frequently asked in the PMP exam. It may be asked twice also in the same exam. So let's see this question on time management. This question is from the time management chapter. So let's start. So to start with, you will be given such a table with activity, its dependencies and durations of each activity. If you see here, activity A depends on the start activity, start node, and the duration is 5. Similarly, activity B is dependent on A and has a duration of 6 days. So the way in which you create the network diagram is this. You put the name in between and you put the duration on the top and the bottom. So to start with, every activity has a start time of 0. There are 2 passes involved. To solve any such problem, you have to go by 2 passes. One is the forward pass, the second one is the backward pass. The forward pass represents the top portion of the flow, and the backward pass represents the bottom portion. So here we will start with activity A. Activity A has a dependency on start, and here activity A has a dependency on start. It has a duration of 5. So we start with the time of 0, add 5, and then it becomes 5. 0 plus 5 equal to 5, obviously. Then we go to B. B has a dependency on only A, so the arrow points from A to B. It has a duration of 6. So this 5 is carried from here to here. Since activity B can only begin after activity A completes, so it will be at the fifth time. I mean, when this completes, it completes after 5 days, say. So this will begin at day 5. So day 5, and we add 6 more days to it, so that will become 11th day. So it will end on the 11th day. So after B comes E. E has a dependency only on B, and it has a duration of 7. So moving this 11 forward, 11 plus 7 equal to 18. So 18 will be put here. Then comes F. F has only dependency on E, has a duration of 3. And this 18 is carried forward. 18 plus 3 equal to 21. So this 21 is the end time for this activity. So it will be completed on the 21st day. So this completes the forward pass for the top flow. Now let's do the forward pass for the bottom flow. To start with, activity C has a dependency on start. So it starts at 0, same as A. It has a duration of 4. So 0 plus 4 equal to 4. Then this 4 is carried forward to D. D has a dependency only on C. D has a duration of 5. So 4 plus 5 equal to 9. And then D ends up in the end activity. So end activity is dependent on D and F, 2 activities. So in this way we complete the forward pass. Now to complete the backward pass, a different kind of methodology is involved. Let's see what is involved in that. So now what we do in the backward pass is we take the maximum duration. So here our duration comes to 9, here our duration comes to 21. So we take 21 and we put it over here, because the logical point here is, even if D completes early on the 9th day, the activity will not end if activity F is still in progress. So activity F completes on 21st day. So you can say that my total time required to complete this particular schedule is 21 days on the 21st day maximum. So this 21st day is carried here, 21, and then we carry on with the backward pass. So 21 minus 3, here we do a minus 3, 18, then it goes backward, 18 minus 7, 11, 11 minus 6, 5, 5 minus 5, 0. And here for activity D, it cannot start the backward pass till activity F has completed. So the maximum duration we need to take over here. So we take 21, then 21 minus 5 equal to 16, 16 is carried forward, 16 minus 4 equal to 12, and that's the way we complete the forward and backward passes. Now another question that will be asked is for the critical path. Critical path is the path which requires a maximum duration. So let's calculate the duration over here. One path is this and the second path is this. The duration for this path is 5 plus 6, 11 plus 7, 18 plus 3, 21. So this takes 21 days and this takes 9 days. So 21 days is our critical path, is the critical path duration, and the critical path is start, A, B, E, F and end. Similarly, another question is of float. Float is the duration that by which an activity can be delayed. So if you notice the critical path, there is no float. Float is calculated by ES minus EF. So 21 minus 9, that brings a total of 12 days. Similarly, 16 minus 4, that also brings a total of 12 days. This should equate, otherwise there is something wrong with your calculation. So this path is not the critical path in our case. This is the critical path, and the critical path is such that the delay in any of the activities on the critical path will delay the entire project. Many times you see that testing is always on the critical path in traditional project development. So they will always put pressure on testing guys to complete the project on time, since if critical path is delayed, if the testing is delayed, then it will delay and it will jeopardize the entire project timelines. So this is the way you calculate the critical path, float and check the dependencies. If you have any other questions, do let me know, do drop in a comment, do subscribe to my channel, and thank you very much for watching this video.